You're listening to Intelligent Medicine, a resource to help you take control of your health. We offer a balanced, objective analysis of all your health, wellness, and aging options, both conventional and alternative. Now you can take your engagement to the next level by joining FullScript. FullScript is my online dispensing platform that only offers curated, professional-grade supplement brands that I know and trust. Never counterfeit or expired, always stored and shipped correctly. Just go to drhoffmanstore.com for more information and to start your free FullScript account. Buying through FullScript offers fast, free shipping, optional refill reminders, a mobile-friendly site. It's safe, secure, and HIPAA compliant and offers world-class support. Just go to drhoffmanstore.com. You'll get access to the supplements and features you need to help you achieve your wellness goals, including my custom targeted protocols that combine the products I recommend to address specific needs, heart health, immune support, and much more. It's all at drhoffmanstore.com. drhoffmanstore.com.
Welcome to Leyla Weighs In here on the Intelligent Medicine podcasts. Thanks for joining me. I'm a registered dietitian nutritionist here in New York City. If you'd like to make an appointment with me, I'm available in person, via telephone, as well as virtually via telehealth. That number is 212-779-1744, 212-779-1744. If you'd like to email me with questions that you'd like to hear me answer, weigh in on, take a deep dive on, topics of interest to do with nutrition, health, wellness, that email is questions@drhoffman.net. That is questions@drhoffman.net. Can probiotics detoxify heavy metals? This is the question. And new studies actually say yes. Probiotics, the good critters, the beneficial bacteria, the beneficial microbiota that live in your gut, can they detoxify heavy metals? Studies say yes. Just so you know, your liver is a primary detoxifier of all things. And when you've got a clean, well-functioning liver, and you're also reducing your total toxic burden in your environment, whether you're macro environment or micro environment, it does make all the difference. Another thing that helps with your detoxification is making sure that your vitamin D levels are optimal. Definitely above 55. We want it under 100. We don't want to go much over 100. And what vitamin D does is it upregulates your glutathione. Glutathione is the main master antioxidant for detoxification. So let's dive into this one, this study. Certain probiotic bacteria, namely Lactoplantobacillus plantarum, Lactobacillus crispatus, and Lactobacillus acidophilus, are able in varying degrees to detoxify cadmium, lead, as well as other toxic metals. These microbial allies may also be able to mitigate damage to the intestinal lining caused by heavy metal exposures. And those are the key signals from a new paper that's published in Frontiers in Microbiology. Though the observations were from in vitro experiments, meaning in the lab, in the test tube, and not in vivo human trials, they provide strong proof of concept that certain microbes can sequester and detoxify toxic metals, and that they hold potential for reducing the toxicity associated with heavy metals that we as humans absorb via our food, our water, even through our air. Quote, the researchers say, taken together, our findings illustrate that probiotic-mediated intestinal bioremediation is a feasible and promising strategy to counteract heavy metal exposure. This is per the microbiologist, the lead microbiologist who was the lead investigator on this new study, Marco Payne. Payne is the chief science officer of Probiotical, an Italian company focused on developing probiotic strains for use in human health and nutrition products. Probiotical sponsored the new study, which was done in collaboration with researchers at the University of Ghent and the University of Piedmont Oriental. So you know this is going to be a biased study. The people creating the nutraceutical, right, are showing its beneficial effect. So pay attention to that. So taken together, the researchers say that the findings illustrate that probiotic-mediated intestinal bioremediation is feasible and it's a promising strategy to counteract the heavy metal exposure in our lives. It is intriguing to note that many Lactobacillus plantarum strains are reported elsewhere to adsorb, and immobilize heavy metals. Our results concur with those reports and even hints that dietary consumption of L. plantarum-rich fermented foods, such as traditional sauerkraut or other lactic acid fermented vegetables, alongside a potentially contaminated meal like a fish dish high in mercury, could help to reduce the mercury absorption in the gut. So, let's talk about bioremediation. The three organisms, Plantarum, Acidophilus, crispatus, analyzed in the current study were chosen based on an earlier in vitro experiment. Again, in vitro meaning in the lab, in the test tube, in the petri dish, in which each microbe was exposed to a mixture of 4 heavy metals, namely cadmium, chromium, mercury, and lead. There were 2 parts to the test. In the first, the bugs were co-incubated with the heavy metal mixture, while in the second, they were grown in heavy metal-free media with the toxin mixture added afterward. All 3 of these well-characterized gut-derived lactobacilli showed the ability to sequester and detoxify the metals to varying degrees. This is interesting. For the current experiments, Payne and his research team use it's a method that they use called the Simulator of the Human Intestinal Microbial Ecosystem. SHIME is the acronym. So they used a particular model, this SHIME that they call, which models the conditions inside the human stomach, the small intestine, and the colon. The SHIME simulator allowed the investigators to test high levels of cadmium, lead, chromium, mercury, and other metals that would be toxic to actual humans. And for the test, the SHIME platform was configured for a dynamic representation of the upper GI tract, followed by a short-term colonic simulation under fed condition. The survival, growth, and heavy metal detoxification capacity of each strain were assessed under sequential gastric, meaning stomach, small intestinal, and colonic conditions. So this is a model they used. So three things to take, and these are the 3 grains of salt. It was done by the company who's promoting a possible product, so it's in their best interest to find a positive outcome to their research. Number 2, it's an in vitro method, this study, not an in vivo method, meaning it's proven in the lab, not in the human body, right? So we have to be careful here. And then number 3, they're using a modeling platform that is there to simulate the conditions in the human body. So 3 grains of salt. So Scheim, this model that they set up, enabled Payne and his team to assess and compare the 3 microbes and measure their relative affinities for sequestering particular metals. The colonic phase is key. They found that L. plantarum, L. crispatus showed strong ability to minimize the bioavailability of these toxic metals, but only in the colonic phase of the Scheim simulator. And in contrast, L. acidophilus showed only a minimal, though measurable, capacity for detoxification. All 3 lactobacilli strains maintained high cell counts through the simulated small intestine, the bile, the pancreatic enzymes, indicating that they could indeed tolerate the biochemical stresses of the small intestinal conditions. But they did not show any heavy metal detoxification activity in the small intestine part of the simulator. Mechanistically, only the strains that proliferated well in the colonic phase achieved substantial heavy metal removal. For all strains, quantification analysis revealed that the samples from ends of ileum simulating environment displayed highly similar heavy metal levels to the blank conditions in which the reactor was filled with heavy metals and to which no bacteria were added, suggesting that small intestine conditions did not enable heavy metal detoxification, according to the researchers. They add that L. acidophilus, which thrives in small intestinal conditions, didn't proliferate well in colonic conditions, which could explain its minimal capacity for metal detoxification. There were also metal-specific variances. The researchers observed both strain-specific and metal-specific variations. Both plantarum, crispatus were able to detoxify lead, cadmium, chromium, and lead to some degree. They said lead twice, so lead, cadmium, and chromium to some degree. But crispatus only showed a particular affinity for lead, reducing the amount of lead in the supernatant by about 45%. Now, both microbes were able to reduce cadmium and chromium by 20 to 40%. That's significant, but again, we're talking about a simulator, right? Mercury was the most recalcitrant metal, according to the researchers. The microbes were only able to detoxify around 10% of the mercury in the test mixture. It is well established that heavy metal exposure can adversely impact intestinal mucosal integrity and intestinal homeostasis, though these effects vary accordingly to metal type and concentration. All heavy metals have an irritating effect on gut epithelium, including inducing tissue stress and inflammation and altering microbiome composition. To assess whether the probiotics could, in fact, protect the GI mucosa, the lining of the mucosa, from heavy metal-induced tissue damage, Payne and his group followed their Scheim simulator studies with an experiment using a gut ex vivo system. This system utilized small intestines excised from freshly killed 13 days old mice, cultivated in a silicone-based gut ex vivo system. This is what scientists have to do to do their experiments. So the intestines were passed through 6 independent chambers, each chamber connected to 2 needles attached to input-output syringes. So they took the intestines of a 13-days-old mice. They took it out and they did it ex vivo. Okay. This allowed precise control of the flow of a nourishing medium into the inner intestinal compartment. Now, at high concentrations, heavy metals tend to be extremely disruptive to intestinal mucosa. Payne's team initially tested the heavy metal concentrations used in the preliminary screening and the SHIME, the model experiments, but found that at these levels, the metals caused so much damage that the intestinal tissue was no longer viable. Wow. The probiotic-treated tissue showed a dampened inflammatory response and a preservation of epithelial integrity compared to tissues exposed to the heavy metals alone. So they ended up testing lower concentrations of heavy metals, which then had a significant impact on the permeability of the gastric mucosa without destroying tissue viability, the GI mucosal permeability. Now, in the mouse ex vivo intestinal system, even these relatively low concentrations did compromise the barrier integrity of the intestines and triggered pro-inflammatory responses. Pre-incubation of the heavy metals with each of these 3 probiotic strains markedly alleviated these effects and restored more or less normal intestinal permeability and cytokine profiles. The probiotic-treated tissues showed a dampened inflammatory response and a preservation of epithelial integrity compared to tissues exposed to the heavy metals alone. So, anyway, the experimental design did not allow the researchers to determine if the protective effect was due to the probiotics' ability to sequester the damaging metals, or whether it was a secondary result of bioactive substances secreted by the microbes that might fortify the mucosal barrier function or maybe downregulate the inflammatory signals. So chronic heavy metal exposure tends to reduce the relative abundance of Firmicutes and proteobacteria while promoting the growth of Bacteroides populations. Functionally, these perturbations can negatively affect gut barrier integrity. So, limited though they are, the current observations do show that the probiotics can reduce the toxic impact of heavy metals on intestinal tissue. Payne predicted that this is most likely through decreased metal bioavailability. So, there are a number of mechanisms through which probiotics like these in this study, like these 3 that were tested, could mitigate heavy metal toxicity. And these include direct binding of the heavy metals, chelation, right? Intracellular accumulation, and enzymatic or maybe chemical modification of the metals. So the researchers characterize the relationship between heavy metal pollutants in the gut microbiota as bidirectional. So it's clear that metal exposures can alter both the composition and the function of the microbiome. For example, chronic heavy metal exposure tends to reduce, as I said earlier, an abundance of certain bacteria while promoting the growth of others. But, as is shown clearly, in these experiments, certain gut-derived microbes can alter the toxicity of the problematic heavy metals and reduce their negative impact on intestinal physiology. This is the core principle of bioremediation. And they say, again here, as I mentioned earlier, there are obvious limitations to these studies. Firstly, they are corporate funded by Probiotical and may therefore contain biases in favor of the company's patented probiotic strains. And since no other probiotic species or strains were tested, the data can't be generalized beyond the 3 strains used in the experiments. Secondly, these are early-stage in vitro experiments and not human clinical trials, or even in vivo animal studies. Whether the observed metal mitigating effects can actually occur in living beings remains to be determined. The researchers acknowledge that the absence of in vivo data limits the translational generalizability of the findings, particularly regarding systemic outcomes and long-term efficacy. However, he stressed that these constraints do not detract from the novelty and relevance of the study, but highlight the need for a cautious interpretation. Heavy metal exposure is a chronic public health condition that source control cannot resolve at the population level. Intestinal bioremediation is the missing piece of the food safety chain. We now have the scientific basis into clinical research. And in future, he and his team plan to test probiotic heavy metal remediation in animals in the hope of confirming the compelling phenomena they observed in the in vitro experiments. The ultimate goal, they say, is to bring this into the clinical real world as a more natural, proactive, and less invasive means to diminish the health risks associated with environmental heavy metal burdens. So, this paper is published in Frontiers in Microbiology. That's Frontiers in Microbiology. And this excerpt that I was reading to you from is coming from Holistic Primary Care. Can probiotics detoxify heavy metals? New studies say yes, but taken with a few grains of salt, as we have to do with certain scientific research. I want to thank you for joining me on another edition of Leyla Weighs In. This is Intelligent Medicine.
I want to thank you for listening to the Intelligent Medicine Podcast. Follow us on Apple Podcasts, Spotify, Amazon Music, or your favorite podcast app, and get new episodes automatically downloaded every weekday. And please give us a rating and review. It truly helps new people discover intelligent medicine. The Intelligent Medicine Podcast is for general informational purposes only and does not constitute the practice of medicine, nursing, or other professional healthcare services, including the giving of medical advice, and no doctor-patient relationship is formed. The use of information on this podcast or materials linked from this podcast is at the user's own risk. The content of this podcast is not intended to be a substitute for professional medical advice, diagnosis, or treatment. Users should not disregard or delay in obtaining medical advice for any medical condition they may have and should seek the assistance of their healthcare professionals for any such conditions. Finally, please visit drhoffman.com and discover everything Intelligent Medicine has to offer, including frequently updated, unbiased health news and fully vetted product and supplement recommendations.
This is Leyla Muden, registered dietitian nutritionist. I maintain a private practice and see patients regularly. If you require a nutrition consult with me but live out of town, there's no need to travel to New York City. I have telephone and telehealth consultations with clients from all over the country. Please visit drhoffman.com for more information. And to set up an appointment, call 212-779-1744. That's 212-779-1744. I look forward to being a collaborator in your healthcare.